Welcome back, everybody, to CSM walkthroughs. This is week 3, and this is question 2. Okay, we're on the last part of our question 2, which is a question for solving the transfer function. So notice that here we use this notation with the omega. Sometimes it's used with the j. It doesn't matter. It's the same thing for this class. And this is also defined as the phasor for V out over the phasor for the Vs. But the transfer function is also referred to as frequency dependent gain. So gain comes from the fact that we are dividing our output by our input, but notice that it's a frequency dependent. So we can't use the V out phasor we solved for in part B, because there we assumed that our omega equals 1,000. So we can't solve for that. So we will just use our symbols, and from part B, we noticed that it was a voltage divider. So we know that this kind of relation is satisfied. So we will use the fact that, this should be exchanged. So we will use the fact that if we divide both sides by Vs phasor, then we get this as our transfer function. So we will use that here. So our impedance for capacitor is j omega c. And our impedance for the resistor is just JR. And our impedance for the inductor is just J omega L. If you want the derivation, you should check out worksheet 2. Okay. Like derivations for the impedances, you should check out worksheet 2. Now, we simplify this by multiplying both sides by j omega c. So that would give us 1 for the numerator. So you multiply both sides by j omega c. And for the denominator, you get j omega rc for the first term, minus omega squared lc for the second term, because j squared equals -1, and just 1. So yeah, that's all for this problem. We expressed our transfer function in terms of resistance, inductance, capacitance, and frequency. Yeah, thank you for watching these walkthroughs. I will come back for walkthrough question 3.